Talking about how to do exponents when they're fractions or when they're radicals. So I want to quickly review the square root of x we can rewrite as x to the 1/2, and the cube root of x we can rewrite as x to the 1/3. The exponent on the inside, which is a 1, becomes the numerator. The 2, which we do not see, becomes the denominator. In this case we can see the 3, and that became the 3 up here. So we're now going to apply this to different problems. For this first example, I went ahead and changed it for us. X cubed times y, quantity raised to the 1/2. Same for this one, except for we're raising it to the 1/4. So we want to take this and multiply it and distribute. So this is going to become x to the 3 times 1/2 is 3/2. Y, 1 times 1/2 is just 1/2. X to the 1/4, and y, 3 times 1 is 3 and then fourths. All we have to do now is group together our variables. So we have x's, and we can say 3/2 plus 1/4, and then y's are 1/2 plus 3/4. I cannot combine these, so I'm going to come on over here and show some scratch work. So 3/2 plus 1/4, I need a common denominator. So we want to make this have a denominator of 2, or I'm sorry, a 4, so we multiply it by 2 over 2. We get 6 over 4 plus 1/4. Well, that I can do 7/4. So x to the 7/4. Same thing with y, except for we have 1/2 plus 3/4. Multiply it by 2 over 2, we get 2 over 4 plus 3 over 4, that is 5/4. Y to the 5/4, that is my answer. Alright, so for this next one, we have two monomials, meaning, no problem. So we have two monomials, so we can simply move both of these up to the top. So I'm going to just rewrite this as a to the negative 3x times a to the x over 2. At the same time, I can distribute this to get y. 2 times 1/2 is just 1. I don't have to write it, but I can. Sorry, I do need to write that in this case because it's 1 minus and then x over 2. So this is the exponent now. So we've taken care of this term, and this term. We now just need to move this other y up to get a positive 2x. Now, this is very similar to the last problem in that we only have two variables. We just need to combine them. Again, I need to show my scratch work over here. Negative 3x plus x over 2. Well, this needs to be over 2 as well, so I'm going to multiply it. So it's negative 6x over 2 plus x over 2. That gives me negative 5x over 2. So a is to the negative 5x over 2. Y is a little bit longer. We have 3 things to add. So this becomes 2 over 2 minus x over 2. This we need to multiply as well. That becomes 4x over 2. So 2 minus x minus 4x is 2 minus 5x over 2. Y is 2 minus 5x over 2. And that is my answer. Okay, so for this next one, it's going to be a little bit different. We do not have two monomials, we have a binomial. So I'm actually just going to break it into like a big fraction. And I'm going to make this 1 over x squared plus 1 over y squared. And then also make this 1 over xy. So I can find a common denominator here by multiplying this one by y squared over y squared and this one by x squared over x squared. And I end up with x squared plus y squared over x squared y squared divided by 1 over xy. Now, visually it's kind of hard to see, but we have these two fractions, and we need to divide by this one, okay? Or, if I see that I have this, then I can just actually make this multiplication, and I just need to flip this. So I'm going to put xy on top, and the 1 on bottom. So I can distribute this out, or I can go ahead and cancel. Oh, I forgot my 2 here. I can go ahead and cancel this. So x cancels with this, y cancels with this, and I end up with just x squared plus y over xy. All right. Our next problem doesn't have any variables, but there's still a good bit of work that can be done. I'm going to start by distributing this radical. So it'll be 3 root 3 over root 2 minus 4 root 2 over root 3 plus 2. I'm going to come over and do some scratch work. Square root of 24 can be broken down into 4 and 6. 4 is a perfect square, so it comes out. 6 is not, and it doesn't break up into any other perfect square, so it stays inside. So I'm going to rewrite this square root of 24 as 2 square root of 6. Now I have to rationalize these denominators, so I need to multiply by root 2 over root 2 for this one, and this one needs to be root 3 over root 3. This will give me 3 root 6. I can multiply them because they're both inside a radical, over, and then square root of 2 times square root of 2 is just 2. Okay, and then we have minus 4 times square root of 6, 3 on the bottom, and then plus 2 times 2 is 4 square root of 6. Now, all of these radicals have a square root of 6, so they are like terms. However, we need a common denominator. Our lowest common denominator would be 6. So I need to multiply this one by 3 over 3, this one by 2 over 2, and this one by 6 over 6. I get 9 root 6 over 6 minus 8 root 6 over 6 plus 24 root 6 over 6. 9 minus 8 is 1. 1 plus 24 is 25 root 6 over 6. I cannot simplify the 25 and the 6 out here. I cannot simplify these two because this 6 is not inside a radical. So therefore, I am done. All right, just 2 more problems. So we have 2 binomials, so we can do FOIL, okay, in case you forgot. First, outer, inner, last. Let's write it horizontally. So we have, first is root 2 times 1. That's just root 2. Outer is root 2 times negative root x. So that is negative root 2 times negative root x. Okay, I'm going to put the negative out front. Inner is square root of x times 1 plus square root of x. Let's move that I over. And then last is square root of x times square root of x. Show my scratch work. Square root of x times square root of x is just x. That's my last term. Now, I could be done, but I could also factor out a GCF between these 2 terms. All right, so both of these have a square root of x. If I factor it out here, I'm left with negative root 2 and a positive 1. Okay, well, I'd rather have the positive in front, so I'm going to keep this term because we didn't change it. I'm going to bring out my GCF. And I'm just going to rewrite these. So the 1 stays positive and the root 2 stays negative. My GCF is here. And then plus x, that didn't change. This is our final answer. Alright, for these next two, we need to remember a couple things. I is the square root of negative 1, and therefore I squared is just regular negative 1. Whenever we have i's, we're going to be looking for either I to the first power or I to the second power. We have two that are not either of those, so we want to break them down so that they are. So it's 3i squared times I. 1 plus 2 is 3. 2i squared I. 2 plus 2 plus 1 is 5. Minus 3i plus 2i squared. That one, these two don't change. Anytime we see a negative or a I squared, we want to replace it with a negative 1. So this becomes negative 1. This becomes negative 1. So does this one. And so does this one. Okay, everything else will stay the same except for those I squareds are being replaced. So 3 and I plus 2 and I minus 3i and plus 2. Now I'm going to multiply. 3 times negative 1 is negative 3i. Negative and a negative make positive and they go away. So it's just positive 2i. Negative 3i. This one becomes negative 2. Now, we need to combine like terms. So negative 3 plus 2 is negative 1. Minus 3 more is negative 4i minus 2. We look like we're done, but we need it to be in standard form. Okay, so over here, you need to know that standard form is a plus bi. A has no I, b has an I. So we always want to write it with the I term second. So we're going to rewrite this as negative 2 minus 4i. Just so you know, A would be negative 2, B would be negative 4. Alright, so for our last example, we have no i's, but we can see that this one, and this one will have an I. So I'm going to rewrite this as root 3i times root 4. Oh, wait, you can take the square root of 4. What is that? It's 2. Let's put the 2 out front. Okay, plus 3. Oh, we can take the square root of 9. So 3 times 3 is 9. So we're still left with an I here. And a square root of 2. Okay. Plus, square root of 16 is 4. But the I comes out. And then this one's just square root of 16, which is positive 4. Alright, so this should be I times I is I squared. Anytime we see an I squared, we replace it with a negative 1. Show my scratch work. 9 root 2 times negative 1 is just negative 9 root 2. So I get 2 root 3i minus 9 root 2 plus 4i plus 4. I want to group together the I terms and the numbers without I. 4 minus 9 root 2 plus 4i plus 2 root 3i. Now, we always want it in standard form, so we want to be able to identify what is A and what is B. Well, in this case, we have two A's, but we can actually just rewrite it as grouped together. So that would be our A. In this case, our B would be everything in front of our i's, so it's our coefficients. So we're basically factoring out the I. So 4 plus 2 root 3. So that's going to be our final answer. Our A is this first parentheses, and our B is this first or the second parentheses, including the I.